Alright, good day to you. This is Anagalactic, bringing you the secrets of the universe, and over here you'll see one of the secrets of the universe that is being explored right now. That is one of the most celebrated astrophotographs of all time. I know several astrophotographers. Just want you to see the great detail in this superb photograph. Look at that. There is so much detail in there. You can see that something is just spinning crazily into the maw of that bacon eating, devouring black hole. Anybody can see that. A child can see that. That is not exactly a photograph, that is commonly conceded, except when you're trying to promote your program in order to get billions of dollars out of the government. You're going to be prone to joining with a group and just, haha, yes, that's of course a photograph of a supermassive black hole. You could say so, or you could join with Dr. Becky, who says that's not really a photograph. It's actually a mock-up of a data set in order to make it say what they would like it to be. And that's fair if you're stupid enough to believe them. A scientist can't afford to do that. You don't believe anybody. So is that in fact a photograph of a supermassive black hole? We won't attempt to answer that directly because it would be incendiary. One thing that Dave Chappelle learned, which he taught to me in one of his comedy sequences, is when he learned the hard way, don't break up a 3-card Monty act because you can lose your life. And the way that Dave Chappelle learned this, at a tender age, he was in his teens, and he tried to break up literally a 3-card Monty game because he lost his last $50 thinking that he had seen through the charade. And of course, he lost his money to the fiends who were stealing money from anybody stupid enough to come to their 3-card Monty game. And the big guy running the operation did not like the fact that Dave Chappelle was trying to interfere with his money pipeline. And so he attacked Dave Chappelle, picked him off the ground, and was going to beat the tar out of him. But then he softened as Dave reports what happened, and he learned a lesson from this thug, and he did not get beaten up. He was turned loose. The guy had gotten his $50, and he must have had some sense of mercy left in him. And so he said to Dave something he related in his broadcast, which I watched. The man, the thug, said to Dave, "Don't ever stand in the way of a man and his next meal. And so I do not wish to interfere with the incredible 3-card Monty game that perhaps is going on, as many top-notch astrophysicists have softly suggested. This is not a photograph. And that you see in the data set mock-up is not a black hole. That is a fact. But what is it? It is something that it is constructed. It is constructed from a data set, which you can read the papers about this highly celebrated, highly promoted, truly incredible photograph. And I'll just continue to call it a photograph because I don't want to be lifted up by the thugs who may exist to protect this system, and I don't want to be beaten to death. It's really a matter of survival. Scientists can only go so far. And I think you understand that Galileo faced the same thing. You don't want to be stepping on the toes of a huge money operation just because you want the truth. The truth has very little to do with money. All right, there's our little sermon. Now, what I'll be presenting to you today is just what that thing actually is. It is called an SMBH, which is a term that has a scalar adjective in it. Supermassive simply means that it is one type of black hole. And there are different sizes. The very first black hole that was ever discovered, called Cygnus X, I believe, was a stellar-sized black hole. And that began the mathematics, of course. The mathematicians were highly aroused by this discovery of what appeared to be a supergravitational object. Now, what we're studying was discovered sometime later, towards the second half of the 20th century. It was discovered that there is a larger sized black hole that exists at the center of at least some galaxies. It was realized at first, and finally, after decades of research, it is now conceded in consensual astrophysical science that a supermassive black hole, that is, I will just call it an SMBH, one of those objects, which can be called an object, I'll just continue to use that general class name, it is considered to be an object of some kind. That object exists at the center of every galaxy. Now, there's always a footnote. And one of my teachers, Fritz Zwicky, probably the greatest astrophysicist of all time, he discovered the third cosmic unit, which is the galaxy cluster. He discovered dark matter as well. And we'll get to that because I have the solution to that really troubling enigma. I think you've heard of dark matter. That was a mistake, but it was the term that my teacher Fritz used, which the way he used it, it was adequate enough because he was an honest scientist. He wasn't really part of a government program such as the modern astrophysicists are all part of a government program. I'm sure you realize that, but you see, that creates bias. So, does this object exist at the center of every galaxy? That has not yet been determined, partially for the reason that it is so difficult to describe the lower bound of what is a galaxy. There are dwarf galaxies, there are gnome galaxies, which are smaller, there are even pixie galaxies, and there's a whole string of names for progressively smaller and smaller galaxies until at some fuzzy boundary, it's hard to tell if what you're looking at is a galaxy at all. Now, I'm not going to talk about that, although that is a bona fide major thread of research that has been going on for decades. But it doesn't directly concern us here. I am simply trying to be precise in my definition of what is a galaxy because it's difficult to say if a SMBH, or really a BH of some size, is indeed at the center of every galaxy. That has not been proved. But for galaxies of our size, the Milky Way and the Andromeda Galaxy, and the nearby elliptical galaxies such as M86, I believe that's actually M87, and those are two Messier objects which are actually elliptical galaxies we know now. Those are quite a bit larger than our galaxy, which is a spiral galaxy. Our galaxy has an SMBH at the center. M86, I'm going to say M86 for now because I think that's the one that was photographed. In fact, I could actually just check right now, but I'll leave that for homework to you. M87 and M86 are both elliptical galaxies. And one of them is the target for this photograph of the SMBH at the center of that spherical galaxy. Spherical is the right term, elliptical is a little bit elliptical. So what I'm going to do today is what many of my listeners have been waiting for. This will cover geometry and mathematics. In order to probe at the cutting edge right now, I will be using the recently released discoveries, major discoveries, made by Neil Turok and his team, which I covered in the last couple of videos. This just came to my attention, but the discovery was made last year in 2025 that the supermassive black hole has more than one possible interpretation according to the Einstein equations, on which the model is based. This has to do with gravity, of course. It is considered to be a supergravitational object, and it could have been named such, but we know what causes gravity, that is mass. You may wonder, is that the only thing that could cause gravity? It is the only phenomenon that we know, that is the only, and it's hard to use a correct class noun, it is the only source of gravity thus far known. That is, it is protonic mass. Protonic mass. That's redundant. It's protons that cause gravity. That has been proved, but you don't hear it said that way that often. I'm not sure why, but gravity is the result of protons all being in the same locality, such that they influence each other and form such things as stars and planets, and in fact, we believe now, galaxies. So therefore, the center of a galaxy, being an SMBH, is a highly compact, to put it mildly, an extremely, actually a hypercompact collection of protons, which then creates a gravitational field which has a mathematical center that simply destroys physics. It stops physics. It's where physics ends, and nobody denies this. Stephen Hawking, Penrose, all the greats, and Einstein knew about this as well, I think, but Einstein's students definitely did. And so this surface, as it's now called by Neil Turok's team, that's the first time that the word surface has been heard in this branch of astrophysics, studying these objects that exist at the center of every large galaxy. Just to give you the scale, if you're interested, you should look this up if you're greatly interested. That's what a scientist does. You look it up yourself. But it is considered to be a black hole of more than 1 million solar masses. So you could study that if you wish, but that is the right way to say it. That's from Wikipedia. So this is a photograph of a 1 million plus. It's actually quite a bit more, but that is how it's defined. And there have been attempts to extend that scalar range to hyper. It's not just supermassive, but there are possibly hypermassive, and that's even more baffling, because one thing black holes all have in common, no matter what scale, the very definition of what it means to be a black hole is that it has a curvature singularity, a term which is freely used by Neil Turok and his team. It is a precision term. I didn't just make that up. It's called a curvature singularity, and that is common to all black holes. Now, this photograph, which I just wish to leave on the screen for a moment until we go on into the mathematics and geometry, what that purports to show is a surface. It's hard to tell or to say where the surface is, but what Neil Turok discovered with his team, there are 3 men who produced the paper, but there are a couple of major institutes in Canada, South Africa, and elsewhere that are collaborating on this enormously significant breakthrough, where the Einstein field equation, which can be thought of as something that's manipulable, but it is considered to be sacrosanct. The Einstein field equation is the basis of spacetime. So this is a spacetime object by default. And therefore it has space-time geometry that is the current cutting edge of physics. Nobody argues with that. Well, there's always a few who will argue with pretty much anything. It's just the nature of science. Not to say they're wrong or right, it's just that they're at the fringe. This is consensual science at its best or worst, depending on how things turn out. Nobody really knows what's at the core of the SMBH. What the Turok team has discovered is that it has a surface. Now that had been known according to the equations, but instead of calling it a surface, it has other names that avoid the term surface, because that's a geometrical term. And it is simply unknown if it has such a surface. What it does have is a mathematical aspect, whereby what Neil is calling a surface is the boundary between the outside of the SMBH, where time-space is curved the way we would expect. But as you get closer to a boundary, a spheric boundary, that once you cross that boundary, there's nothing rational. There's nothing at all except chaos. And it's worse than that. It's actually completely indefinable. The mathematics cannot penetrate past this limit. What the Turok team has discovered is that there is no real need to do that, because what's inside that surface is the reflection of what is outside. And in the Kirchai-Mungol interview, which was conducted 9 months ago on his station, a 2.5-hour presentation, if I recall correctly, it's worth every minute. It's worth every minute. And I've covered that in a prior video, just a couple of videos ago, cursorily, because 2.5 hours, that's quite a bit of information. It's all cutting-edge information. So what I will be doing today is extrapolating on the Turok discovery. I'll just call it the Turok discovery for now. He's actually the third listed name on the paper, issued just last year, announcing their discovery of what they call the Black Mirror. The Black Mirror. That refers to a surface that they discovered. It's a reinterpretation of the mathematical depiction of what this thing is, whereby prior to their paper, there was nothing inside that could be probed mathematically, and therefore nobody knows what to do. The Turok team has discovered, in their view, exactly what to do. What is inside the surface of the supermassive black hole is the reflection of what is outside. And that matches the geometry that I discovered. I can give a mathematical basis to what they discovered, which is rather interesting to try to state summarily, without the proofs and without the technical jargon. Every scientist should be able to do this. It is an art, because you have to leave out a lot in order to summarize what you yourself believe that you see. So I'll state that now. That what I discovered 3 years ago about the surface of the SMBH, which has just been discovered. So you could say I discovered it first. That's an interesting thing to try to say. I don't assert that to pat myself on the back. I did discover the same thing that the Turok team discovered, but not mathematically specifically. It was from a geometric approach that does have a mathematical proof behind it. That's what I'll be describing to you today. In the same way that the Turok team is now able to say that the inside of the SMBH is a reflection of what is outside, I will be able to extend that definition, flesh it out, and make it real, physically real. What they're saying is a mathematical interpretation that has a physical description which they do not claim to have proved. That would be very difficult to prove the physical reality of what's inside the SMBH. But what they discovered is that there is a mathematical reinterpretation of the same equations used to just stymie physics really to death. They're attempting to resurrect physics. Of course, so am I. All of us would like to see physics get back on track. That is not going to be possible until we can figure out what is inside the singularity. And that is a curvature singularity, which, let me interpret that for you. It is a spheric surface. Well, I discovered the geometry of the spheric surface. It may sound preposterous, but I have given over 1,000 videos on that discovery. It is not a parlor game. This is not a mathematical exploit. In other words, just to produce another theory. I try to avoid theories. Technically, we all try to avoid theories. You make up a theory, and you have to say you make it up because you can't prove it. You make up a theory to fill in the gap where your knowledge ends. Your ability to prove has ended, but you know there's more, and so you guess. You make an educated guess. That can be quite deceiving, and that summons up everything we know about bias and prejudice, so we're on our guard with theories. There are exceptions to that, of course, having to do with money, but I've covered that, and I'm sure you're well aware of the dangers of doing science for money. What Neil Turok points out quite cogently, and rather amazingly, I should say, from my point of view, is that this spheric surface has its own geometry. That's a major insight, is that the surface is actually conceivable as a geometric object, which means, quite simply, that it has an outside and an inside. The computation based on the gravitational profile of the object that needs to be performed achieves a spheric singularity. And that is such an important term, I should give a brief definition, and pardon me if you already know what the definition is of a singularity. But it does have more than one definition, and I won't go into that here. Suffice to say that a singularity is where the mathematics must stop. And the reason it must stop is that it has achieved an infinity. This is not just mincing words. When your mathematics is computing a gravitational field, it is, in this case, a supermassive object. The nature of gravity, Newtonian gravity, and now, of course, the extension of Newtonian gravity to a space-time formulation, which really does not change the Newtonian definition of gravity, which is a simple formula based on a square law. The space-time formulation of gravity attempts to introduce space curvature, which Newton did not surmise. He did not suggest that space might be curved. Einstein, of course, did suggest such a thing. And you see that in all the diagrams that are taught to all the children. So this is definitely government approved, and you can't argue with it. So we know now that space is curved. I do not challenge that. But what that means when you get to the surface of the SMBH, that formula achieves infinity. It goes to infinite gravity, which resulted in quite a hullabaloo when this was first modeled. That what is inside that surface, which is a mathematical projection of a gravitational field to where the gravitational concentration, it's going in, it's getting stronger. So as it goes in and gets stronger, it goes to infinity, and that can be computed using calculus where that boundary is, leaving a hole inside that surface. What has been thus far projected, modeled, based on that gravitational profile, is that gravity as we know it increases to this spheric surface, and precisely at that surface goes to infinity, and that's the end of the computation. But you see, that infinity is always a monstrous problem. The same sort of problem occurred in what was called the ultraviolet catastrophe, which Max Planck probed and discovered quantum mechanics thereby. So this has a lot to do with quantum mechanics, which is why you hear very often quantum mechanics at least mentioned in connection with this phenomenal object. So the surface is now what we're interested in, because the Turok team has discovered that it is a surface that has a computable property that gives us our very first view of what's inside that infinity. Which is a strange thing to say, and Neil is perfectly well aware that that's a strange thing to say. Well, whatever we end up saying, it's definitely going to sound strange until it can be proved. That's why I'm here. I'm going to prove what the Neil Turok team is attempting to prove. I can prove it. So this will validate their work. And so now we need to get into the mathematics, which may alarm you. I would not blame you if it did alarm you. Oh my God, more calculus, more complex numbers, more things that I did not have enough schooling to understand. Believe me, I'm being perfectly honest. I am more afraid of that than I think you could possibly be. But by a miracle, I was able to solve for this infinity. So why are we now able to say, as I do say, that that surface called the curvature singularity is a bona fide geometric object inside of which we can now directly probe using the mathematics approaching the surface from the outside? What the Turok team has asserted, but are unable to prove, they're simply showing this is a new interpretation of the Einstein field equations, which should be stated as plural. That they are now able to state hypostatically, that is hypothetically, that is theoretically, they are now able to state that it is possible to say what is inside that singularity based on the mathematics that essentially defines that surface from the outside. They have been able to show, basically using conformal geometry, using something called the CPT, which we're going to get into, and something called, it's actually called analytical extension. The exact term, we're going to get to that. Don't worry about that, because that actually is a little bit daunting. But it is one way of using the mathematics that proves there is a singularity. You can use that same mathematics to prove that the way that you prove there's a singularity demonstrates that you can reflect the same mathematics and discover what's inside on a reflection, which is why they called this surface the black mirror. The black mirror. This would be a spherical mirror that does not reflect outwards, it reflects inwards. And that is exactly what is sought. So this is a major breakthrough if it can be proved. It can be proved. I'm going to prove it to you now. It's interesting the way Neil Turok extrapolates what this might mean for humans. That is how we would actually see this, visualize it. That's the goal. Always in science. It's to visualize what you've discovered. In this case, it's not possible, or it has not thus far been possible until last year, to visualize what's inside a spheric surface infinity called a curvature singularity. There is nothing inside, and you can't even say that there's nothing inside. You simply can't say anything at all. That is a fairly good definition of what is conceived to be the black hole. That there is an enigma at the center. So that is an infinity. What I'll be showing you right now is that it is possible to rationalize that infinity. That's essentially what my geometry is able to do, is to rationalize an infinity. Technically, it's the rationalization of two infinities by combining them using a new form of mathematics called proportionality. This has been known for millennia, and the newness is simply how to exploit a new number system based on two componency. And that can be done to parameterize the plane, which means it can also be done to parameterize physical space. That's what I proved. So that's a major insight that is so far unknown to consensual science. That's why I have this station, is to promote that geometry as a major tool that has never been known to science and now is necessary in order to probe the quantum limit, which is a spheric surface, and the supermassive black hole, which is a spheric surface. And these are strongly related, but they're related on something that cannot be probed with linear mathematics. And there's a reason for that, which is difficult to state in just one sentence because there are so many different ways of stating it. And any way I do state it will suggest answering a lot of questions having to do with the other ways of stating it. So this is profound. I just basically gave you a profile of a super profound discovery called intrinsic geometry. This is non-Euclidean geometry, and it uses non-linear numbers. So let's start there, and my goal will be to attach what I say to the black mirror. So picture a sphere, and now we're just going to want a slightly better image than this mock-up of a data set which has been, I'm sorry to say this, but it's propaganda. It's propagandized. That is not a photograph, and that is not a black hole. Okay, now here you will see our image of the black mirror. Where is it? You will see three concentric circles. In this particular image, the central circle is highlighted in red. There are two concentric circles outside of that. We're going to use this very simple diagram in order to probe the black mirror, which we're going to say for now is the outside circle. It's called a curvature singularity because it's the same in terms of what's inside and what's outside. It's the same everywhere at the perimeter. So that is where science ends. What's outside is normal physical space. What's inside is absolutely undefined, which is a problem because science needs to know what's inside. We're going to find out why that's so important. The surface is called the circumference. Now here, you know that this is a 2D projection of a sphere. So the center, labeled either 0 or O, you may see that that's in italics. That's not a 0, it's an O. But the numbers going along the x-axis in the positive direction are the counting numbers. So this is the traditional definition of distance. Now, on the inside of the singularity, there is no definition of distance. Nothing is defined inside. So this is an overlay of a grid inside the singularity. It does have dimensionality. We know that because gravity cannot go to zero. However, the mathematical model of gravity is that it does go to zero and it keeps going. So it transcends the origin, essentially turning everything inside out. But the mathematics breaks at the surface at infinity because the numbers become meaningless. And so really by definition, there's nothing inside that can be measured or even imagined. And so it's proper to say, and I will say, that what is inside the curvature singularity, labeled 3, the number of concentric circles. So the circumference that you see there of a circle represents the circumference of a sphere that has been flattened according to the way we see a sphere. And the radial lines just spoking, the spokes that come out, that is the radius of what's inside. You could say that it is the integral radius, which can be conceived as a pressure. So what's happening is that gravity pressurizes inward and gets stronger by the square law as it concentrically collapses toward the center, which is just one way of saying something very difficult to say, but that is the principle of gravity. Now you might ask, does the gravity of Earth go to infinity at the center? I leave that for you for homework, but in the case of a supermassive object, it is essentially quite a bit different. Gravity is a monopole, which is why physicists, about half of them, don't like to say that gravity is a force. Newton said that gravity is a force. But modern physicists, following the discovery of the space-time model, they no longer like to say that gravity is a force because there's no motion. Newtonian force is based on motion. But gravity is not based on motion, it's based on curvature of space. Now you may object and should object, there must be some force that is bending space. That would be a redefinition of the word force, where there's no motion involved, but it is a force of some kind because it's changing a property of physical space. In this case, space itself, which is a brand new idea, that space can be influenced by a pseudo-force. That would be the proton. That much is known, because what makes mass is the number of protons. That's a simplification, but it is adequate for our purpose, which is what? It's to figure out the surface, which currently is conceived as an infinity. That's why it's called a curvature singularity, is because this circle representing a sphere has the value infinity. That is a most interesting thing to say, because can a surface have the value infinity? When you look at it, you would have to say no. It can't have the value of infinity for the simple reason that you can see it. It's obviously not infinite. It's a presence in space because there's an inside and an outside. The inside and the outside must be related. And the problem has been thus far, for decades now, is that the mathematics fails at the curvature singularity. All the numbers go to infinity. That's the end of your computation. It ends at the surface. Well, it's time then, you would perhaps suggest, what are the characteristics of the surface? Until Neil Turok and his team gained an insight into what that surface actually implies about the inside, it simply did not imply anything because it's an infinity. And so we're going to say, with what you would probably call the traditional interpretation, or however you phrase it, the Einsteinian interpretation of that surface is that it has a pseudo value of infinity. You might ask, infinity of what? Well, this is a representation of gravitational force, which outside is computable. But as you approach the curvature singularity, as you approach it, the numbers head to infinity, such that to the proportion that you achieve that surface, you achieve infinity. And so you could say that the surface of that sphere, called a curvature singularity, has the value infinity, which is an imaginary number. That's one way to phrase it. It's quite difficult to talk about infinity. Really, we can't imagine infinity. That's why it's a problem. But then you could just simply state, as far as you're able to state anything, is that is an imaginary number, which has a name, infinity, which cannot be a number. So there's an innate contradiction in stating that there is a curvature singularity, because it's now imaginary. What would be inside that is undefinable. It's undefined what's inside of it. But we do have a partial definition of the boundary between physical space and what you might just say is anti-physical space. That's proper, and that is exactly what Turok says. But what is meant by anti would be the surmised or hypothesized interior is anti-space. What does it mean to say anti? That's what they propose that they have discovered, is what anti means in this context. What they have discovered and can at least show mathematically, it's not strictly speaking a proof because there are no strict proofs in this. It's a model. It's a remodelization of the mathematical equation of gravity, whereby at the curvature singularity, that's where your mathematics halts. It halts the machine. It's a CPU fault. And so everything stops. You just drop your pencils, turn off the computers, and go home. You're done. You found what you were looking for. It's something that you cannot define. So you would have to say that that's imaginary. So we are going to say that. Not only is the space inside characterizable as being anti-space, which we have not defined, we're just saying that's its characteristic. It's not only anti, it's also imaginary, which is a term that has several contextual meanings in mathematics, one of which is magnificently exploited in the complex number plane. Now, that is not specifically what I'm saying we're looking at, because I think you're probably, if you're reasonably rational, you're petrified by the very idea of complex numbers. You should be afraid of them. They're quite magnificently challenging. But they do have a function, and that's where we get the major current use of the word imaginary, because a complex number is a two-component number, one component of which is imaginary. The other one in contradistinction to an imaginary number, is a real number. And that makes two kinds of numbers. When you conjugate these two numbers, produces quite a miracle in mathematics, the ability to compute curvature using a number system that captures the concept of curvature, which the linear number system cannot and never will. But the complex numbers break that barrier with a most interesting construction on the plane. We cannot go into that now, although I've given several videos on that, and in fact one whole video series on the nature of the complex numbers, which uses the word imaginary in a very useful context. So now we've made a little bit of progress thus far. We've stated that the interior can be theorized coherently as being composed of imaginary antispace. What more might we be able to say? Not much more, unless you can parameterize the surface, which is the singularity. What's inside is not the singularity. The surface is the singularity, and what's inside had been undefined until the Turok team, now in conjunction with my own insight, were now able to at least characterize what can be reasonably stated might be inside. With mathematics, with a geometric construction, which would be necessary to visualize what is inside the infinity. So does indeed this curvature singularity have the value infinity? Yes, it does in linear mathematics. It does have the value infinity, which is a direct contradiction of physics, because you can see the surface is there. So it is not infinite. Why does linear mathematics state that the curvature singularity has a value of infinity? It's because the numbers break. The system breaks. And the reason that the numbers produce an infinity where it must not be is that the linear number system uses add as its operator. I proved that, so just accept that for now. If you're dubious, you can either consult my prior videos, or you can just go along with the show, not being quite convinced that linear mathematics is based exclusively on the addition operator. But now I'm going to show you, by coming at this question from a slightly different angle, that there is another operator which does not produce an infinity at the curvature singularity. And the way you get rid of that curvature singularity, which has the value of infinity, is that you state that that surface value of the curvature singularity, which you can see, it's a sphere. It's a sphere. And it's the surface that's the singularity with the value of infinity. What if you're using the wrong number system to compute that? That's what's happened. The wrong number system was used to define that singularity. The reason it is a singularity is because you're using linear numbers to approach it. And the linear number system does have a zero at it as its reference frame. What I was able to show that that zero only applies to the operator add. That's been proved rigorously. That will be in my paper. But there is one other identity number, and you've heard of it. It's called 1 to the proportion that 0 is the additive identity. 1 is the multiplicative identity. That's what we're taught in school. That's been proved. So there are two identity numbers in mathematics, and only two, because there are only two operators. There is add, which has 0 as the reference frame, and there is 1. I'm sorry, there is what we call multiplication, and that has an identity value of 1. Now, in the linear number system, the reference frame is always at the center. No matter how many lines you draw, even in spacetime, all 4 orthogonal lines intersect at 0, and that is a number in the linear number system. It's the reference frame for distance. None of this is new. I'm just stating what we already know so we can get to the end of the diving board and dive. What about multiplication? That does not have a reference frame of 0. And the fact that we cannot divide by 0 rather proves that, although I don't see a whole plethora of proofs of that, because that's actually a little contradictory to the whole Geist, the whole spirit of linear algebra, which is the ability to compute distance in space. That's what linear algebra has always been used for. That's the basis of the most popular science book of all time, called Elements by Euclid. Quite an old book. So, what I am able now to show is that you can use a different reference frame for a different use of numbers. And this has been known for a long time, but it's never been fully explored, certainly not to the extent that I've explored it. Quite basic, and I would say the only challenging thing here is that it's so obvious, you would have to ask, why am I the first man to be able to talk about this new number system? Is it new? It can't be new, because only the linear number system possesses a subset of the linear number set called the representable numbers. And those are practically synonymous with the computable numbers. And I am now able to prove why our computers use the binary number system, which is not a linear number system. What it is a linearizable number system. But 1 over 2 obviously has 2 numbers in it, but we treat it as if it were a linear number. That's proper in one context. That's the basis of science right there. But you have an inverse of that, and it's not the additive inverse, whereby a plus quantity and a negative quantity add to 0. In the multiplicative system, really the binary system of numbers, 2 numbers, instead of adding to the reference frame, which is 0, they multiply to the multiplicative reference frame, which is 1, which is a representable number. But it has an interesting representation in the binary number system. It's 1 over 1, which we say is one of the first things we learn in school. If you have 1 over 1, you can reduce it. That's a change of dimension. You're changing a 2-component number into a 1-component number. When you do that, you've recovered the linear equivalent of that 2-component number. When you do so for multiples of 2, for instance, 2 over 1, instantly you realize that that is a representable, computable linear number. Well, it's not linear, it's linearizable. So 2 over 1 reduces to 2. So far, so good? So far, so good. But those are 2 different representations of what we are taught are the same number. There's a real interesting trick involved in saying that, whereby you might challenge that. If you can write 2 as a single number, which would be, you could say, a quantum number, because it represents 2 of something. So it's a quantity. Well, that number then is a quantum number. So 2, 4, 8, 16, these are binary counting numbers, but they're not written that way. They're always written with that line and the 1 is underneath. You can reverse that. You can actually invert that. And if you do so with the positive power numbers, which would be 2, 4, 8, 16, these are powers of 2. 2 to the first is 2 over 1. 2 to the second is 4 over 1. 2 to the third is 8 over 1. You can invert that. And in fact, we do that on something called the power line. You see that the linear numbers 1, 2, 3, 4 go in sequence, just as always. They're counters. They're called counting numbers. But they're used in a specific context where the quantity they're representing is in power space. This is kind of an interesting thing to be able to say. Sounds a little science fiction-ish. This is quite basic. This is the basis of the definition of the binary number system used by all computers, whereby you skip 3. Is 3 a representable number? Yes, it is. So that is part of the representable number set. Is it computable? Yes, 3 is a linear number that is computable because it's not irrational. It's a rational number. So 1, 2, 3, 4, all of those numbers are rational. So when you write them over 1, they're all still rational. The definition of rationality is 1 over 1 is the center number, and that's 2 to the 0th power. And that forms the center of the power line, exactly the way Euclid set up the geometric line. Only now the numbers have a different meaning, so that the center number 0 is a power of 2, and 2 to the 0th power is 1. That replaces e to the I pi equals -1. That used to be called the most beautiful formula, or equivalently, the most beautiful equation in all of science, which I used to think until I discovered the real winner. Miss Universe in the equation contest is 2 to the 0th power equals 1. Nothing irrational about that. Can that be proved? Yes, it has been proved. So that, although it sounds strange, that 2 to the 0th power, wouldn't that be 0? No, it can be proved by analytical extension that that actually is the number of unity. It's the number 1, the counter. The first counter is 1. And the definition of that number in binary space, which is a 2-component number system, is that 2 to the 0th power equals 1. That is by far the winner. I probably deserve a Nobel Prize just for that, but you'll see as we proceed that I deserve dozens of Nobel Prizes. That's a little grandiose, a little almost megalomanic. I don't expect that that's going to come true in my lifetime. Perhaps not ever. Perhaps this is just a wild goose chase. No, it's not. So 2 to the 0th power puts 0 at the center of the power line. And now if you use the counters, and only the counters, you get all the positive binary numbers, beginning at 1. And so the lowest number in the binary system is 1. How far does it go? It's an infinite progression. So there are an infinite number of binary numbers, and that is called a number set. Can it be extended to a number system? That's what I discovered. Yes, it can. So we now have 0, 1, 2, 3, 4, and these are the indices of the numbers in power space. Are there negative indices? Yes, there are. Oh my God, yes. Otherwise, we could not get numbers less than 1. We can get an infinite number of numbers less than 1. They exist in the binary number set if you simply extend the power line from the positive to the negative, whereby the first power number on the power line is -1. We know what that is. When you write 2 to the -1 power, that's 1 over 2. That's called the reciprocal of 2 over 1. You may notice that they balance on the center number, the same way that +1 and -1 balance on add to 0. In this space, 2 over 1 multiplied by 1 over 2 balances the two numbers on the reference frame of the binary number system, which is 1 proportion 1. That line between the two numbers is not division, because that's a linear concept, and this is not linearity. This is binarity. That's the new number system that I discovered. The computers already knew about it, and so our mathematicians simply fed the computers the number system that the computers like. And they certainly work well when they're fed two-component numbers in binary space. So that's the binary number system, which has a reference frame number of 1. Is there a 0? No, but there is a... You could say yes or you could say no, depending on what you mean if 0 is in the system. It's not one of the numbers. But on the power line, it definitely exists, or we wouldn't be able to balance the system, because there has to be a center to a number system. In this case, that number is 1, not 0. And so all the numbers balance on 1. When you go this way in the positive direction on the power line, you get 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 248. It just goes on. 2048, 4096, and then 8192, and then 16,300 and something, 84, I think. And it just keeps going infinitely, but not linearly. It's not a linear progression, but the power line is a linear progression. So that's where you have linearity in the binary system. It's the power numbers. So now we have full access to linear space, and that is well known. So we don't lose the computable numbers. In fact, we're defining the computable numbers based on the counters, and this is purely rational. So we have a center number of 1 proportion 1. That's written 1 over 1. Over means proportional to, and that's non-commutative. And here's why. If you have 2 over 1, the first binary number in the positive direction, 1 is neither positive nor negative. 1 proportion 1 is the center of the system. In linear space, that's considered to be positive. In this space, it's not, there's nothing anti-positive. The positive numbers begin at 2. That's the first positive number after the center number. So the center number is 1 proportion 1. The first counter is 2 proportion 1. And then it goes up according to the power line. 2 to the third, 2 to the fourth, 2 to the fifth. If you go in the opposite direction, you get the reciprocal of the entire positive set. So those are the negative numbers. Now we don't think of them as negative. It's a different definition of negative. The power numbers are negative. -1, -2, just like on the line. So that's the linear representation. That is, the linearity in the system is the power numbers. -1 produces 1 over 2. So 2 to the negative first times 2 to the positive first equals 2 to the 0th. So you simply add the power numbers. That's addition. It's the addition of the power numbers. And so the actual numbers begin at 1, that's the center number. It's neither positive nor negative. It's 0. It's 2 to the 0th. So that's the 0. It's the power number that establishes the reference frame for this system. In the next video, I will show you that the true value of the curvature singularity is not infinity, it's 1. And in fact, it's 1 proportion 1. But that's only for the circle, because you need a 2-component number to represent something on the plane. And that number for the circle that we're looking at is 1 over 1. 1 proportion 1. 2 to the 0th power. 0 is a linear infinity. That's where infinity is. So when it is said that the curvature singularity is infinity, not exactly. You can change the number set to denote that rationally so that infinity goes away. It actually disappears into the power system, which is not directly the numbers. That 0 is not a number in the system. It's a power number that defines a number. And that does have a 0. You need a 0 to define 1 in binary space. So the actual value of that circle is 1 proportion 1. And that changes everything because now 1 over 2 is inside that circle. 1 over 4? What about 1 over infinity? 1 over infinity has to be at the center. And so that's at the center of the SMBH. What had been conceived as having to be 0 is not 0. It's 1 over infinity to the proportion that the numbers going out end at infinity over 1. If you multiply that 0 at the center, which is now translated to 1 over infinity, the smallest number in that number set is an imaginary number. 1 over infinity, as we just discussed, is an imaginary number. To the proportion that you're approaching by going in from the surface, which is 1, you're getting closer and closer to 0 on Zeno's paradox. If you break that paradox by achieving the goal, which is the center, you achieve 1 over infinity, an imaginary binary number. That exists to the same proportion as the edge of physical spherical space, which has a value now in proportion to the center value, neither of which is real. But they're the only 2 numbers in the system that are imaginary. And if you multiply them together, you achieve the same result as when you add plus infinity and minus infinity on the line, you get linear 0. In this space, when you multiply 1 over infinity at the center times infinity over 1 at the edge, you get the curvature singularity. And on the projection downward onto the plane, that has a binary representation. So you multiply the 2 infinities and you get 1. So that is the value of that circle. That has a value of 1 proportion 1. And now to blow your mind and end this at only 80 minutes, a little less we hope after editing, when you are able to state, as you now can state, that the curvature singularity has a value of 1 proportion 1, you can also state what is the sphere. That circle that you're looking at is the eigencircle of a sphere. And it is an eigencircle because it captures angular momentum. That's a lot. That's a whole fucking lot. I'm sorry to overwhelm you, but now's the time to blow your mind. That curvature singularity is a projection downward from spherical space, whereby you're looking down the pole of a sphere which might be rotating. Physics has proved that every sphere in the universe rotates. You can look that up if you'd like to prove that to yourself. Good luck. But it is provable. So every sphere is rotating. When you look down the axis of the rotation as you're doing now, then you have the value of angular momentum on the surface. Can you compute the sphere of that circle? Yes, you can. It's a 2-to-1 proportion, which is a miraculous statement. I told you I should be getting a lot of Nobel Prizes in the future. It's a little more complicated than that. Let's not have any more discussion of fantasy. I'm not going to get any prizes for this unless you spread the word. Good luck in trying to explain this to someone else, but I will explain it to you, and anybody who wants to listen to this video can find out the value of the spherical curvature singularity, which defines the supermassive black hole. What is its value? It's 1 proportion 1 proportion 1 proportion 1. That's one of the most amazing statements that has ever been made in the history of mathematics, geometry, or physics. Completely solving the quantum paradox, by the way. And if you're interested, I have 1,400 videos published which describe that. And the supermassive black hole, which now releases astrophysics to redefine everything we've seen so far in the universe, using the correct mathematical basis. Thank you for tuning in. Keep looking up. We have a waning full moon. It's now in the gibbous phase, heading towards the new moon, which will be towards the end of February. Keep looking up, my darlings. I say that every time for a reason. That's the basis of religion. As you start to study the cycles of nature, especially the cycles in the sky, you will come to know Allah. May His name be blessed forever, and may His love be part of your life. That's what He wants. We'll be right back.